Hello and welcome back. Today we're going to go through C++ vectors. C++ vectors are dynamic sequence of information of the same data type. So C++ vectors use contiguous storage locations for their elements, which means that their elements can also be accessed using offsets on regular pointers to its elements, just as efficient as in arrays. So in arrays we saw that given an array, like ARR 2, 3, 4, 5, we could have accessed each element as, let's say, array of ARR of 2 this will be equal to so this element is the 0th element, this is the first element, this is the second, and this is the third element. So ARR2 will be 4. So this is 4. So similar to this way of accessing array elements, we can do it with vectors as well. So what I mean by that is I can have a vector, let's say vec. Vector and arrays more or less they look the same way. So here 2, 3, 4, 5, and I can access the third element, which is with index 2 equals to 4, is the same, and is sufficient to access by index. Then the next question is, what is the difference between vectors and arrays? So the third point illustrates this. The key difference is that in vectors their size can change dynamically, which is not the case with arrays. In other words, we can say that vectors are kind of dynamic arrays. So whenever we define an array, we have to define the size of the array before actually start using the array. For example, if I have to declare an array, I have to mention the size of the array 5. So this will create me an array of 5 integer elements. Now, unlike arrays, I can define vectors without actually specifying the size of the vector. For example, if I in C++, if I need to define a vector, I can just declare it like this, like vector is a keyword in C++ and vector of int, and then give the name of the vector as ARR. And if you notice, I didn't specify the size of the vector. So before using the vector ARR, I have to make sure that whenever I am accessing the elements of the vector ARR, the element is there. For example, in this via this declaration statement, the initial size of the vector ARR is 0. So if I try to access the first element as ARR of 0, this will throw an array out of bound error, because I'm trying to access the 0th element, whereas the current vector is of size 0, it doesn't have any existing element. So here in the two diagrams I have shown two representation of contiguous storage locations. One is the array which has a 5, 6, 7, 8 and then 9. So the here array size is limited to only 5 elements. In case of vectors, we can also have the same numbers like 5, 6, 7, 8, 9, but at the same time I can add a new one, 10. I can just increase or add a new element to the existing vector without actually have to create a new vector of size. In this case it is 1, 2, 3, 4, 5. So, and instead of creating a new element with size 6 and then copying them one by one, which is not required in case of vector, but is the case if I want to increase or add a new element to the array, I have to create a new array with size 6 integers, and then I have to copy one by one and then add the last new element 10, which is not the case with vector. We can just add a new element to the existing vector in constant time. Here are some of the common operations that are available in C++ vectors. The first one is the pushback operation, which is used to append a new element to the vector. That is, if I already have a vector, let's say 3, 2, 3, 4, and I want to add a new integer 6, I can do this by using the pushback function, which is like if this vector is known as reference using the variable name back, I can just do back dot push underscore back, and then I can just give the element 6. And then next is the insert operation, which is used to add a new element to the vector at a specific position. The third is the pop back, which is to remove the last element from the vector. For example, here 2, 3, 4 and 6, if I want to remove the last element 6, then I can do that using the pop back operation, just like back dot pop underscore back. And then the last operation is the erase operation, which is to remove an element from the vector at a specific position. So we can specify a particular location in the existing vector, and we can remove that element from the vector. Now, to get an extensive list of such C++ vectors operations, please refer to this link.